Good morning. I'm Samana Shrestha, and I'm going to give a short lecture on static friction. So before we start static friction, we should know what friction is. Friction is basically it's the opposing force. So this is the opposing force when two bodies come in contact with each other. So if a body moves or tends to move in this way, then the frictional force comes from this way. And there are so many types of friction like static friction, kinetic friction, rolling friction, and so on. The friction is it depends on the path. So whenever one body slides or tend to slide or rolls over the other, due to the opposing force friction, there is some loss of energy in the form of heat. So the friction is a kind of it's a non-conservative force. Yeah, because of the static friction, in the real world we see so many examples of static friction, like this object sits here properly on the top of any object, like we can pile books in stack, the cars on the ground. So these are examples of static friction in the real world. Uh, how does the friction come from? Let's see. Say there are two objects in here. There are two bodies in contact with each other. Though these surfaces in contact seem very smooth, but there are so many irregularities, projections in here, in between them. So when I apply force, external force from this direction, these irregularities get interlocked with each other, and this object cannot slide from here because there is the opposing force, the frictional force from the opposite direction. So we need to provide excess force to overcome this frictional force such that this body slides on the other. Now, in the case where the body is not sliding, the body is just sitting on top of the object, still there is frictional force in between these surfaces. So this type of friction is the static friction. However, I'm applying external force from here. The frictional force is from the opposite direction. I keep applying force. The static friction still keeps increasing, and as the external force exceeds that static friction, it starts to move. And this friction that comes into play now is called as kinetic friction. However, whenever the body rolls, then that type of friction is called as the rolling friction. There are so many factors on which the friction depend. The friction depends on the roughness of the surfaces as well. More the roughness, more is the friction. So people use lubricating agents like grease, oil to reduce the frictional force between these two objects. Now let's see. As I said, let me explain the static friction in a graph actually. So I'm applying external force from left to right, whereas the frictional force acts in the opposite direction from right to left. I increase, let me show this in graph. This is the external force, this is the frictional force. As I apply external force, because this is not moving, here is the static friction being applied here. So the static friction increases. I still increase the externally applied force, the static friction still increases. I increase the applied force, static force increases. I increase the external force, the static friction increases, and so on. So with the increase in external force, the static force increases. It keeps increases until the externally applied force is sufficient enough to overcome the frictional force. So this is the maximum frictional force in this case for the body to be stationary in here, and this friction is called as the static friction. Now, as the external force applied reaches to the static friction, now the friction quickly drops, and with the increase of this external force, with the increase of the external force, now the body slides. The body slides with constant friction. In this case, the friction, as the body slides, the friction now that comes into play is called as the kinetic friction. So this is the kinetic friction, and we see here the kinetic friction is less than the static friction, and the kinetic friction is constant though. The static friction increases, becomes maximum until the external force matches the static friction and then quickly drops, and then the friction then applied is the kinetic friction. Then the body accelerates depending on the force, external force we have applied. So this is how we explain static friction. Now let's see. Say here is an object of mass m. Here is an object of mass m. So the forces being acted on this body are the force due to its weight, or say gravity, in vertically downward direction. So here the value of gravity is 9.8 meters per second square, but I will be using 10 meters per second square for calculation to be easy, because I'm going to explain the static friction, the relation between static and the kinetic friction, by giving a short example with numbers. So we take z to be 10 here. So one of the forces being acted on this body is due to its weight in vertically downward direction, and the other is the normal reaction in vertically upward direction, and this object is horizontal, is on the horizontal surface. The normal reactions, say R or N, whatever. Now, as I said, if the external force is applied from this direction, the friction is from this direction. The friction is this from this direction. Until the body moves, the friction being applied here is called as the static friction, and the static, or whatever, the friction in this case depends on the normal reaction N. And here the body being on horizontal surface, the normal reaction is balanced by the force due to its weight in vertically downward direction. So these two forces are equal and opposite, and they cancel with each other. That is why this body doesn't move up or down, as the net force here is due to N and mz is 0. However, this body might move left or right depending on the direction of force we have applied, and depending on the frictional force as well. So this frictional force depends on the normal reaction, and removing this proportionality sign, there comes a constant mu, where mu is a constant called as the coefficient of friction, and this mu being the ratio of two forces, force, externally applied force, and the normal reaction, which is also a force in newtons. So mu, the coefficient of friction, is a dimensionless quantity. Again, if I'm talking about the static friction, that means the externally applied force is not sufficient enough to overcome the static friction. Then in that case, the static friction is given by mu s times n, where mu s is the coefficient of static friction now, which again depends on the type of material of the surfaces in contact. Similarly, now if the external force applied exceeds the static friction, it begins to slide, it begins to move. Still there is a frictional force, and this frictional force is called as the kinetic friction now. Here, as I have shown here, the kinetic friction is less than static friction. That is why the body is moving. That means the opposing force is less than before. That is why the body is moving. So in this case, the kinetic friction is given by mu k times n, where mu k is the coefficient of kinetic friction again. So these are the two important equations for static and kinetic friction. Now, as the kinetic friction is less than static friction, so the coefficient of kinetic friction is less than the coefficient of static friction as well. Let me explain this in numbers. Say I have a body of mass 5 kilogram resting on a horizontal surface. So the force due to gravity in downward direction is going to be 5 times 10, that is 50 Newton. And this is sitting on a horizontal surface, so the upward force, the normal reaction, N, balances the weight mz, and hence it doesn't move up or down. And let's say the coefficient of static friction between these surfaces of contact is say 0.4, and coefficient of kinetic friction, and the coefficient of kinetic friction is 0.3. Now let's see how much is the static friction and how much is the kinetic friction. Now Fs being the static friction, which is mu s times n, and mu s is 0.4, so 0.4 times n. N is a normal reaction which is equal to mz, and m is 5 and g is 10, so 5 times 10 is 50. 50, and I get 5 for the 20, so 20 newtons. 20 newton. That means 20 newton is the opposing force on this body. So the externally applied force should be more than 20 newton, should exceed the static friction, so as it just begins to slide. Now let's see how much is the kinetic friction. Kinetic friction is mu k times n. Mu k is 0.3. 0.3 times the normal reaction, which is mz, is 5 times 10 is 50. As I did here, 50. So 3 times 5 is 15 newton. So the kinetic friction here is 15 newton. Now let me explain this, relating everything, relating this. The static friction for this body of mass 5 kg is 20 newton. So if I apply a force of 10 newton from left, this body doesn't move. It doesn't move, the acceleration is 0. So the friction here is static friction in this case. So if I increase the external force, say from 10 to 12 to 14 to 16 to 18, still it is less than 20 newton. Still it doesn't move. However, if the externally applied force reaches 20 newton, so it just begins to slide then. After that it just begins to slide, and the friction quickly drops. The friction quickly drops from 20 newton to 15 newton. It just begins to slide. The frictional force decreases, which is 15 newton. Now the force, the external force, if I apply here, is 25 newton, which is sufficient enough to overcome the static friction. This body will now move. However, the kinetic friction is just 15 newton, whereas say the external force I have applied is 25 newton. So the difference between these two forces, which are in opposite direction, 25 newton and 15 newton, which are in opposite direction, so the difference between these forces is 10 newton. So the net force being applied on this object is 10 newton, and this force is greater, so the body moves in this direction. That means, let's see. Now the net force being acted here is the difference between these two forces, which is 25 minus 15 is 10 newton. So this 10 newton of force is sufficient enough to slide this body with an acceleration of a. So I'm using here Newton's second law of motion. So the net force being acted here is 10 newton, the mass is 5, and a is the acceleration. So a here is 2 meters per second square, or in the direction of the higher force, and 25 newton is the higher force. So we see that how we are relating static friction with kinetic friction for a body which was initially static and then started to move with certain acceleration. So initially the acceleration was 0, and now the body is moving with an acceleration of 2 meters per second square. Yeah, I think with these pictures I have shown here, and a small example I showed here, I might have made myself clear regarding the static friction. Thank you.